Hello everyone. In this lecture, we want to discuss applications of logarithm. And one of the applications of logarithm is actually in the science of chemistry. In chemistry, there is something called pH scale. And if you want to know what pH is, it is actually a measure of acidity or alkalinity of a substance. There are some substances that have acidic properties. Some of them are considered as alkalines. And this so-called pH scale is actually a logarithmic scale. A logarithmic scale uses powers of 10 to compare numbers that vary greatly in size. Normally, that's the way it is. For example, very small and very large concentrations of the hydrogen ion in a solution influence its classification as either an acid or a base. So this so-called pH number will determine if a liquid or a substance is acid or alkaline. So we have this scale here. The pH scale starts from 0. It goes all the way to 14. And the pH of pure water or distilled water is actually 1. And if you have a pH number that is less than 7, such as 6, 5, 4, 3, 2, 1, 0, then the substance is considered as an acid. But if the pH number is more than 7, 8, 9, 10, all the way to 14, then it's considered as an alkaline. For example, we have acid rain or tomato juice or lemon juice, vinegar, or battery acid. All of these are different substances, different liquids that are considered as acid, and their pH number is less than 7. But other substances, such as baking soda or soapy water, for example, or liquid drain cleaner, these are all different liquids or substances that are considered as alkalines. And these substances have different concentrations of hydrogen ion compared to distilled water. So obviously, the concentration of hydrogen ion in pure water or distilled water is 1. But then if you have, let's say, tomato juice, whose pH number is 4, that has a concentration of hydrogen ion, which is 1000 moles per liter. And the unit of measurement is moles per meter. Or in case of baking soda, for example, the concentration of hydrogen ion compared to the distilled water is 0.01 or 1 over 100. So here in this column, you see the concentration of hydrogen ion compared to distilled water. And we see that these are all multiples of, I shouldn't say multiples, they're powers of 10. So we have 10, and then we have 100, we have 1,000, 10,000. So it's like 10 to the exponent of 1, 10 to the exponent of 2, 10 raised to the exponent of 3, which is 1,000, 10 to the exponent of 4, and so on and so forth. So when we compare two rows, which means two substances or two liquids with two different pH values, let's say pH of 6 and pH of 5, of course we know that both of these substances would behave as an acid, but acidity of a sample with a pH equals 5 is 10 times greater than the acidity of a sample with pH of 6. So this chart clearly shows the concentration of hydrogen ion compared to distilled water in this last column. So the formula, the logarithmic formula, is pH equals negative log, and this is common log, by the way. I mean, the base of the logarithm is 10. Negative logarithm of concentration of hydrogen ion in terms of moles per liter, of course. That's the unit of measurement. This is how you calculate the pH. It's a formula. It comes from mathematics. It comes from the applications of logarithm, and it is used in chemistry. Those of you who have taken any chemistry courses in the past, I'm sure you have seen this pH. There has been discussions about pH in your courses. And once again, what is a pH? pH is a measure of acidity or alkalinity of a substance. That's what pH is, and it is represented by just a number. It's a number from 0 to 14. And as we said, if the pH is less than 7, that liquid is considered to be an acid. If it's more than 7, that liquid or that substance is considered to be an alkaline. And if it is equal to 7, it's just neutral. We have a simple question here. It says calculate the pH. Okay, calculate the pH. If the concentration of hydrogen ion is 0.0001 mole per liter. So there's only one formula. So nothing is complicated here. So we're going to start by writing the formula. pH equals negative log of the concentration of the hydrogen ion. And because we have the concentration, so it's going to be negative log of 0.0001 as per the given information. And we can write the number in terms of a power of 10. That's 10 to the exponent of negative 4 clearly. And then we're going to use the power law of logarithm. So the exponent becomes a coefficient for the log itself. And because I said this formula has a common logarithm, the base is 10. So what would be log of 10 base 10 in your opinion? I think it's going to be 1. Log of any number to the same base is always equal to 1. So when you multiply 1 by 4, you end up with 4. So this means that the pH of this liquid or this substance was equal to 4 actually. So if the concentration of hydrogen ion is 0.0001 mole per liter, then that means that the pH number is 4 on the scale. And because this 4 is less than 7, so what we can say about this substance or liquid, whatever it is, we can say that it is more like an acid, okay, because the pH number is less than 7. There's another example here. It says pH of a lemon juice is 2, so they tell us where we're standing on the pH scale, on this logarithmic scale. They say pH is 2. We don't want to calculate pH, but then instead it says calculate the concentration of the hydrogen ion. So again, the formula is just what it was before, and this time we can sub in 2 for pH, and we have to sort of work backwards to find this concentration of the hydrogen ion. And I believe in this case we can multiply both sides by negative 1, so negative 2 equals log of H plus, and then we can apply the definition of logarithm. So the base 10 raised to the exponent of negative 2 would equal to the concentration of hydrogen ion, and 10 to the exponent of negative 2 is actually 0.01. So we're going to say moles per liter as the unit of measurement would be the concentration of hydrogen ion in this lemon juice, whose pH number was actually 2. So either pH is given to you, they ask you to find the concentration, or like the first example, they give you the concentration, you need to find the pH. But this is not a big deal. It's a simple formula, and I think it can be done by anybody. Thank you for your attention.